Hey gang, this is Sean here with Cisco. I've been meaning to do a couple of these tabletop reviews, overviews of new products, and kind of starting a YouTube channel. So I figured what better way to start this than with an exclusive product. This product will not be on the market for another 4 weeks. This is the Nexus 3548. This would be a switch that's really geared towards high-frequency trading customers, financial service providers who are looking for the ultimate in low-latency switching. There's right now with Cisco, this is a custom ASIC. We're not using any off-the-shelf components, no merchant silicon like a Broadcom chip or an Intel Fulcrum. This is our custom ASIC. Codename Monticello. So I just wanted to start this off, kick this off, and we'll go over the unboxing. This is probably very few units. I think I heard on the East Coast was only 1 or 2. So we got a very special privilege here. So let's go ahead and get started with the unboxing. So in my last clip, I apologize. There's a lot of background noise. I am actually in my home office. So have a lot of gear always running, had a bunch of switches, had some other stuff running. So it was just too much noise. And yes, you did hear me right. I am actually going to unbox a 3548, which won't be out for another 4 weeks in my basement. And we're going to do some hands-on testing. We're going to set this thing up, go through some of the new features. But let's go ahead and get started. Let's cut this box open and see what we got. I'll move it a little closer here. Oh, look at this. Very cool. Very cool. So let me move this box flap out of the way. Let's get this out of here. Now my understanding is this is not a FCS first customer ship unit. This is a prototype, and as you can see here, it is clearly marked. Smaller than I thought, and I'm very glad for that, because I was afraid it was going to be as big as like a 5K, but it's not. It's more like a 2000, and probably much like the 3064. So let's go ahead and get this thing opened up. There we have it. So let me get a nice good clear picture here. So this is a 3548P-10G. You can see we have the Precision Time Protocol input here. Console, USB, management interface, RJ45. And then 48 ports of 10 gig, 1 gig with the SFP, 10 gig with the SFP plus. And I heard, now I'm not sure if this is going to be right from FCS, but I heard that these ports can actually operate in 100 megabit. I'd have to do a little more investigation on that. It's just something that I heard might require some kind of a breakout cable. But so there we have it. There's the technically that is the back of the unit. I still believe. And let's go ahead and take a look at the front. All right, get that lined up there. Now, as you can see, there's 4 fans here. These come right out. Let me just pull this bad boy all the way out for you to see. So these are blue in color here, like a bluish green. I'm half colorblind, so I apologize. But that's indicating this is forward airflow. And what it means is this is the back. This is actually considered the front of the unit, and the port side is the back of the unit. So this would actually be bringing the fresh air or the cold air in from the front of the unit and port side exhaust. If you needed to reverse that airflow, there is another option, the reverse airflow option. And these fans would actually be red. The label here, the color code would be red. And that would actually also have the arrow going in the opposite direction. So that would be, the intake would be from the port side, and the exhaust would be on the front of the switch. So there's your options. 2 power supplies here for redundancy. And let's see if there's anything else from the unit that's really standing out. These power supplies, they are 400 watt apiece. That's about it. Let's fire this bad boy up and get on the CLI and see what we got, what's new. So I'm going to go ahead and take a break here, and we'll come right back and go into the CLI. Alright guys, so one thing that I definitely wanted to go over was some stats before we jump into CLI. This is kind of our second half here, our second part. I want to go into some of the stats, some stuff that I observed, just initially poking around in there. So, just to reiterate, 48 ports, SFP cages, SFP plus cages. The thing here is, when I was poking around, I could see that I could set it as 1 gig, I could set it at 10 gig, I could set the interface at 40 gig, and then 100 megabit. So those options are all there from software. Now, first customer shipment, the very first release of code, the 40 gig and the 100 meg will not actually be there. But it looks like the versatility here is that you could take a couple of ports, let's say 4 ports in a port group, and actually combine those for 40 gig, or conversely, you could take a port and then break it up into multiple 100 meg interfaces. So that's what I noticed as far as the physical interfaces. We're talking 960 gigabit here, so whatever way you slice that, you're still at 960 gig, or 48 ports at line rate 10 gig full duplex. The other thing that I definitely thought was awesome was we doubled the buffer. So from the 3064, which had 9 megabyte of buffer, now we're at 18 megabyte of buffer, packet buffer. So that was very cool. We also increased the unicast routes. I forget what they were on the 3064, but considerably we did bump that up. Multicast is still 8,000, so that's still exactly what we had before on the 3064 in terms of scale. But the big numbers here are the Algo boost. So, running this in ultra-low latency is what they have up here on the slide. That's the default out-of-the-box profile. 250 port-to-port nano. Warp drive, which will go into warp mode. Excuse me, Star Trek fan. Every time I see that, I say warp drive. Warp mode, 190 nanoseconds, and warp span, which is an interesting concept we'll go into a little bit, 50 nanosecond port to port. Now that is a many to one, like a multiplexing functionality, probably big in colos, where you're taking the market data and you just want to have that same feed go to all those other ports at the lowest possible latency. The other really awesome thing here is this active buffer monitoring. I thought that was really interesting to be able to have the visibility into your traffic coming in and out of the buffer. NAT at ultra-low latency, basically you're not taking any penalty when you enable NAT. Static NAT is there. Day 1 dynamic NAT will be coming, and then intelligent traffic monitoring. So that's something that a lot of feedback from our customers. We need more visibility. We need much more granularity from a time sample perspective. So this is all part of the actual ASIC, the Monticello or the Algo Boost engine. So that's just kind of a quick rundown. Definitely want to get that out of the way before we get into CLI, just to give a high-level overview.
And here we are at the startup screen. So no, this is a lab device. We do not need strong password standards here. We don't need to enforce that. Let's go ahead and give this a password. And no, I will not tell you what my super secret password is. We do not want to go into the basic configuration, although that is an option where it can walk you through like a wizard. A wizard. Alright, let's get started here. And we're in. So let's do a show ver. What do we got? What are we working with here? We got 503A1, build 0.393. So this is obviously not CCO code. And we got our system image, our kickstart image, or we got our BIOS, 3548 chassis, 48 ports of 10 gig. Intel processor, x86, 4 gig of RAM. And there we have it. So let's start with, let's see what features we have. Most everything's going to be disabled right now. Actually, yeah, the Telnet and SSH are the only ones enabled. So let's go ahead and give this a host name. We're going to call this N3548 Proto. And let's go ahead and start enabling some features. So we definitely want a little bit of BGP here. Getting a message, LAN Enterprise Services license not installed, not found. We're doing the honor system here, kids, so we're going to keep proceeding. We're good. Interface VLAN, that's always a good thing. Let's do feature EIGRP, one of my favorites. Again, we're getting that message, no big deal. LAN base, LAN Enterprise Service. Here's a new one, feature NAT. A little bit different. LAN Enterprise Services package failed. That's okay. Let's see if we have our command here. And we sure do. So that's cool. As you can see, it's static NAT only out the gate. Dynamic NAT will come later. So let's say our inside local is 10.1.1.1. And we're going to go ahead and translate that to, let's go with 41.1.1. Very cool. Alright. So that's good to go. You always want a little bit of PIM. Yeah, we don't have that license, but we're working off the honor system here. That's cool. Let's see if there's any others. I think that does it for now. So let's see what switching mode we are in. We're going to go show hardware profile warp span. Now that's not what we want to do. We want to do show hardware. Profile forwarding mode. Now here's what's interesting is you see this is not forwarding mode is not on the list when I do my context-based help, but it is definitely there. It's a hidden command. I'm not sure if that's just because we're working with non 1.0 code for this release. I'm not 100% sure, but that command is definitely what we want. Show hardware profile forwarding mode. If I could spell, we would be good. So we're in the normal forwarding mode. You can see the breakdown of the cam there. T-cam, we have 16,000 for unicast, 8,000 for multicast. I wonder if there's a detail. No. So if we want to switch this over to warp mode, and pay attention here because, again, this is not in any of the documentation. This documentation's not out yet, but if you were participating in an EFT and you wanted to change the mode, you would actually have to, I'll show you, there's no option there. You see TCAM, that's the first thing I thought. Region, yeah, is that something we can work with? No, that's not it. So let's just do forwarding mode, warp drive. This command will take effect only after saving the config and a reload. Okay, we'll take its word for it. Let's take a look and see if we, there we go. Allocations are different. We're now at a host TCAM of 8,000, unicast 4,000, multicast is still 8,000, and layer 2 entries 8190. So this is the mode we want to be in. Obviously it's not going to take effect until we reload, but let's get some other stuff configured here while we have the CLI. So I had a couple predefined interfaces I was working with. Let's add those. Let's bring these interfaces up. That's good. Show, let's see what we got in here. Show interface, E115 transceiver. What do we got? E115 transceiver. Alright, so we're working with some twin acts. SFP 10 gig, 5 meter. Alright. Got a 3 meter and a 5 meter here. They are both twin X cables, both 10 gig. So this is good. So interesting enough, I was playing around with some of the other optics I have, and I have the 10 gig FET. Now the 10 gig FET is only for the it's really made. It's an SR optic. It's made for the fabric extenders, so the Nexus 2000s. Going to the parent switch. So the parent switch could be a 5K, parent switch could be a 7K, but the FETs were designed for that. Now for a lab environment, I tried something very interesting. I went into an interface. Let's go interface E1-1, and we say service unsupported transceiver. Now you see, we get this message here. I type this in. When Cisco determines a fault can be detected, can be traced back to the use of third-party installers, it's a legal disclaimer that we put out there. So basically, in a lab environment, you got some optics, they're not Cisco, maybe, heaven forbid, an HP or something else. You can use this command. We do not recommend to run in production with that. Also, when you try to call an attack, I'm sure you might hit some resistance there once they find out that that's not a Cisco transceiver. But the bottom line is, I did not have HP or any other optic. I had Cisco FETs, which are supposed to be only for the parent switch to the FETs. And I plugged them in here, and they actually worked fine after I put this command in. So, kind of sidetracked. I apologize, but that was a very interesting observation. The other thing that I noticed is if we go into interface E11, for example, and we type in speed, we got a whole slew of options. We have 10, 100, 1 gig, 10 gig, and 40. You say, well, hang on a second, is this 40 gig interfaces? I thought this was 48 ports of 10 gig. Yes and no. So the option will come out later down the road after, this is going to be post FCS. where you could take 4 ports. I believe this is how this is going to work. Combine 4 ports in a port group and use some kind of a cable to join those 4 ports and create one 40 gig interface. So this is not here today. This will not be their first customer shipment, but it is coming down the road. Conversely, there's going to be something I believe that's going to give us the ability. Now, 10 meg I have not heard of, but I did hear the 100 meg, and I believe that as well as 40 gig will be coming in later release of code. That's probably going to be some other type of breakout cable, I'm assuming. So just something very interesting there. It might not even be a breakout cable. It may just be a certain transceiver we put in there. So just interesting observation. Alright, so we are in warp mode. Warp mode will not take place until we restart. What else can we look at? Let's look at the active buffer monitoring. So I believe we do monitor. Let's see how we did that. Buffer monitor. I'm learning that the show hardware profile is pretty much going to be the gateway for everything here. So buffer monitor brief. Okay, we don't have that enabled. That's fine. Let's do that. Let's enable the buffer monitor. And I don't have multicast set up in this lab, but let's just go ahead and do some unicast stuff here. And we could see now we have a 1 second, 5 second, 60 second, 5 minute, 1 hour in the buffer block 1, buffer block 2, and buffer block 3. And if you remember earlier, we were talking about 16 ports being mapped per 8 megabytes. So 1, 2, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8. So 16. There we go. Those are 3 blocks of 8. So there we have it. That is that. Let's go ahead and let's push some packets here. I'm going to go ahead and hook up. I don't have any 10 gig hosts, so I'm using a 5K improvising here. Let's see what we got. And I don't have another 3548. I wish I did, but like I said, this is very limited. We have a very special treat here. Definitely a great privilege to have at least even one of these things. So let's go ahead and I believe I went ahead and added those interfaces. Let's first see what we have here. Alright, so I got a 192, 168, I believe it's 254 for the other side. Let's go ahead and ping that. Alright, that's actually our 3548. And let's go ahead and try the other side. This is just another interface here. That is also the 3548. So let's get a full port-to-port going here. Let's do 2.1, sourcing that on the A side of my VRF. So basically it's going to go up from the 5010. It's going to hit the 192.168 1.254. This is all routed. And then it's going to come over to the B side on the 3548, just layer 3. Simple routed interfaces, and then it's going to actually come back down to VRF-B on this 5010, which is VLAN 2 interface. Keep in mind, when you look at these statistics, when we look at the ICMP response time, this is mostly all done in processor. So this is not hardware. The best test we could have would be just a straight up layer 2 VLAN, no IP on the 3548, and then a host, 10 gig host, pinging each other. That would be ideal. Unfortunately, I don't have that gear right now in my lab, so I had to improvise quite a bit. So let's go ahead and see what we got here. I'll do a count of 250 with a packet size of 125. You guys in market data, you like that number, I know. And you can see we're under, for the most part, we are in the microsecond range, 900 mics, you know, somewhere around there. Again, this is all software. This has no real bearing on the performance. I really got to get some 10 gig host and to show you. Let's go back to the 3548. Just out of curiosity, let's ping. Let's just look at our interface first. Let's ping 192.168.254, sourcing it from 192.168.1.254. This is just interface 115 to 116. They are not switch ports. Those are layer 3 routed interfaces. Let's bump that up. That happened way too fast. You can see the difference there, though. Keeping it on the same switch, we are in the 400, 500 mics. So let's do a count here of 200 packet size. Let's do another 125. Oh, that's looking good. That's awesome. Again, not a good indication, and we really need to do the testing right, but just goes to show this is a super fast switch. I mean, on the 5K you do that, you're not getting those numbers. So you can see there is a difference here, and we haven't even restarted, so this is not even running in warp mode. Although with our test, I'm not sure that would make any significant difference. But there you have it. Let's go ahead and look back at that the buffer monitor. So that was show hardware profile, buffer monitor. Let's do a summary. Yeah, we really need to push these things, you know. I got really no traffic. I need a Spirent or an Ixie in my basement. That's the next thing I need. You laugh one day. Let's see. You know what? Let's do let's go into an interface, specific interface. Oh, that's cool. What do we got here? So you can see that's like 1 second samples. As close to real time as we're going to get. This is what our customers were asking. They were asking for this. They really needed more visibility, and we delivered here. I wish I had, you know what, let me try to flood this thing. See what I can do. Yeah, this will not be able to even put a dent in what this thing could do. Yeah, we're definitely we need some serious stuff to generate some load. I mean, we got nothing really to work with here, fortunately. Yeah, it's nothing. So something cool here, you can see the 30-second input-output rate as well as the sampled 5 minutes. So always love that, not having to change load intervals on an interface and then switch it back. Yeah, I just love that feature. So let's see. I know that I had some more stuff here. Let's see what else we have. Oh yeah, this is a great command. So just like any of the Nexus platforms, you're going to have a lot of the internal show hardware internal commands, and this I'm guessing the MTC USD is the Monticello ASIC switch on chip. So we did port status front. That's front port. That's a lot of data. Quite honestly, I don't even know what this is. Maybe one day. Let's see what else we got. Error log. That's the one we just did there, front ports, mapping. I was right, Monticello. So that's the internal code name for this ASIC. So everything we're doing here is you're getting right down the ASIC level here. Too much geeky for me. That's a little bit overboard for myself, quite frankly. It's awesome. Don't get me wrong. It's awesome. I just take me forever to decipher what we're even looking at here. Key here is if you want to look at ASIC info, get down and dirty. MTC USD is your Monticello ASIC. So that is it's going to be a really good command. I'm sure there's going to be a lot of good stuff there. Right there it says Monticello forwarding. So that pretty much concludes our overview here, the CLI. The key here is the warp mode. It is a hidden command. So when you want to change that, make sure you go in there, hardware profile forwarding mode warp. If you want to disable it, you would do no hardware profile forwarding dash mode warp. And the buffer monitor, what a great tool this is. Now I did notice it's either or, unicast or multicast. So in many financial service providers, HFTs, sure these guys are going to be going with the multicast option, just because that just seems to be, that's where the switch is going to live. We're getting the information from the exchange and handling to fiend handlers. So yeah, I think this is a great switch. This is definitely put Cisco ahead of the game. I'm glad we're out before our competitors, and I look forward to covering the switch more in detail. But this was our introduction, a little bit of a summary. Hope you enjoyed it. I hope it was beneficial. Thank you.